it's kind of interesting that everybody in epistemology claims to be a fallibilist, but it's not altogether clear what fallibilism amounts to, or it's not everybody in epistemology claims to be a fallibilist, but a lot of people do. And it's not clear what it amounts to, or why it's a good idea. And in particular, the problem seems to be if you say, well, I could be wrong. On the one hand, that seems a perfectly true thing. And it seems also to be a perfectly proper confession of intellectual humility. You know, who are you? Of course you could be wrong. On the other hand, it seems to collapse either into dogmatism or skepticism. And that makes it problematic. If you take the I could be wrong too seriously, you seem to be endorsing skepticism because you're not taking a stand on your belief. But if you take the I know too seriously, then it seems as though you're a dogmatist. So I'm not going to worry too much about skepticism here, but I am going to worry a bit about the other pole, the worry about backing into dogmatism, which I'm going to actually say you don't quite do, but you come perilously close to. And we'll see why and why this may be worrisome. And I'm going to do this initially with respect to knowledge, because that's where talks about fallibilism typically take place. But I will then argue that fallibilism is better understood as an attitude with regard to understanding. I think everything's better thought as an attitude towards understanding, so that's my general epistemological stance. But even leaving that aside, there are going to be worries about fallibilism that I think we can avoid more if we say it has to do with understanding than with knowledge. So part of the question is, you know, if you say, I know, but I might be wrong, what are you saying? Now, there's a couple of things that you might be saying that are innocuous and you don't want to worry about them. One is you may be saying, it's not a necessary truth. Of course, there's a logical possibility that I'm wrong, or there's a conceptual possibility that I'm wrong, but believe me, I'm right. That might be what you're saying, but that doesn't seem to actually do enough work for us, because we have to ask, you know, what kind of might are we really interested in? Okay, we'll say it's an epistemic might, and that means something more than my evidence doesn't entail my conclusion. It means there's some real possibility of some sort that you're wrong, and we have to try and tease that out. Now, one way of teasing it out is to think about what you might be denying. And the deniers, the kind of most famous deniers, perhaps, are David Lewis and Fred Dretske, who think we should be infallibilists about knowledge. They say you reach a threshold, and then you're infallible. You couldn't be wrong. Now, how are you going to do this without sounding completely off the wall? And the answer is to limit the range of concerns you think you need to deal with. So for Lewis, you only have to worry about being wrong in nearby possible worlds. For Dretske, you only have to worry about eliminating relevant alternatives. And so you circumscribe the range of cases you have to concern yourself with and say, I'm covered within that area. I don't need to worry about demon worlds. I don't even have to worry about remote possibilities. So I get to be infallible. Now the problem with this is, even if we set aside skeptical worries, which I'm happy to do for the moment, there are other cases that should worry us, in particular things that we might call lottery cases. So a lottery, you're winning the megabucks is very improbable. It's, you know, 1 in how many million? You're really unlikely to win. And you have better evidence that you're going to lose the lottery than for virtually anything else you claim to know, like where you left your coat. It's vastly more probable that you are going to lose the lottery than anything trivial. But somebody who's in exactly your position actually wins. And since she's in exactly the same epistemic position as you do, and she didn't know, it seems really iffy to say that you know. Or to go from the nice error of winning the lottery against your confident belief to the unfortunate case that Jonathan Vogel talks about, which has to do with knowing where your car is parked. But cars have been stolen from that neighborhood. So are you quite confident that you know where your car is parked, given that last week cars were stolen from there? The man with his car stolen last week was in exactly the same epistemic situation as you are. So if he didn't know, you don't know. And these are somewhat remote possibilities, but they're in the range of the knowledge predicate. It's not saying you've gone logical, you've gone conceptual or something like that. So there's a worry here about trying to adopt a dogmatic position. But fallibilism, as I said, I think falls between two alternatives. One is the skeptical position. I might be wrong, then I don't know. And every time I say I might be wrong, there's one more thing I don't know. The other is I know, but I might be wrong. Well, is that anything other than mock modesty? The dogmatist says outright, I know. And you add this little, I'll be modest about it, predicate that does no work for you. That doesn't seem a very comfortable position to be in either. But I think the situation is such that you can actually say there is a difference. Despite this similarity, there is a difference between what we want to say with respect to the dogmatic position and the fallibilist position. And it comes out in the inconvenient way that they're subject to different paradoxes. So we have, in the case of the dogmatist, Kripke's dogmatism paradox. Kripke, by the way, does not endorse this. He just thinks that this general conception of knowledge leads you to it. And he's not happy about it. So we shouldn't trash Kripke too much on this. The paradox goes like this. If S knows that P, then P is true, because after all, knowledge is factive. If P is true, then any evidence against P is misleading, because after all, P is true. So to avoid being misled and to preserve your knowledge, or to preserve her knowledge, S ought to disregard any putative evidence against P, which is to say, she ought to simply disregard contravening evidence. Preserve her knowledge, be dogmatic, then she knows. Now, this is not actually a paradox. It's an inconvenient result. It's a totally unwelcome result, but there's no paradox involved. It becomes a paradox if you say that knowledge is also keyed to rationality, and rationality requires open-mindedness and being willing to entertain contravening evidence. That's how you get an actual paradox, but whether it's a paradox or not, I don't think we need to worry about. It's just something you shouldn't be happy about. Call it an enigma, a conundrum, a mess, whatever. Okay, so that's a kind of case where you might say we're really not happy being dogmatists. So how about the fallibilist? She said she might be wrong, so she's at least in principle open to evidence that might in principle be misleading. How about that? That gets her into a different paradox, which is to say a variant of Moore's paradox. So let's do straight Moore's paradox first, where Moore's paradox is, it can be put either as P, but I believe that not P, or not P, but I believe that P. And the problem with this is, as Bernard Williams puts it, you give your assurance with one breath and take it back with the next. Now, this is all about belief. It's not about knowledge, and it's first personal. There's nothing paradoxical or inconvenient, although maybe a bit unwelcome, about saying P, but Andy believes that not P. You know, there he goes, wrong again. We could say that third personally, but first personally, there's a problem. However, the cases I want to talk about, I'm going to call the knowledge variant, which are, I know that P, but not P, but maybe not P, or perhaps not P. It's not exactly Moore's paradox, because first of all, I've eliminated the first personal element because Andy knows that P, but maybe not P, is equally problematic. Knowledge is a stronger claim than belief. So on the one hand, it's weaker because all I've said is maybe not P rather than not P. On the other clause, it's stronger because it's knowledge rather than merely belief. So it's a variant. And it's this variant that I think is going to cause a problem for the fallibilist. And the reason is this. Think about what you can do with knowledge. Well, you can fully endorse it. Use it as a basis for inference or for action when your ends are cognitive, regardless of the stakes. Because if you know it, it's true. You can take it to the bank. But maybe not P means don't fully endorse it when your interests are cognitive, at least if the stakes are high. And similarly with regard, I mean, this is just a variant on what you can do with it, but it's important to bring it out. One of the things you can do when we're talking about something you know is you can testify to it, give others to believe it with full confidence. You can take my word for it. And you know, you're safe doing that. But if I say P, or I know that P, but maybe not P, what am I supposed to be saying? Well, you can use it for inferences, but you probably shouldn't. Well, you can take my word for it, but it's really not all that secure. Well, I mean, there's no utility, no cognitive utility to the claim that would be made with the knowledge variant of Moore's paradox, because you're giving it with one breath and taking it back with the next. So you haven't got the full hesitation of maybe not P, and you don't have the full assurance of P. So this, I think, is a very, let's say, a disappointing or irritating outcome that neither dogmatism nor fallibilism puts us in a particularly happy position with respect to knowledge. And that is part of the reason why I'm inclined to move on and talk about understanding. You know, having backed myself into this corner, I'll try and approach things from a different corner and suggest a couple of things. One is I asked, one of the questions was how we understand what fallibilism is. And the standard view, which people like Adam Leidy take very seriously, is that you acknowledge you claim to know that P, but acknowledge the possibility that not P. And I think that's not a happy condition to be in. So I'm going to suggest that actually that actually fallibilism isn't really an ism. That is, it isn't really a doctrine, but it's more of a stance. It's more of a stance of intellectual humility with respect to understanding. And I'm going to try and spell out what this means and why it might be a good stance to adopt. If we take this view, we get what I call the understanding variant. Understanding is a systematic set of cognitive commitments that collectively hang together. Some are reasonable only in light of each other. Others are independently reasonable, but collectively they give us a take on a topic. So I'm talking about understanding a topic, not understanding just that so-and-so is such and such, or that why so-and-so is such and such. So it would be understanding physics, understanding baseball, something like that. And you have a whole bunch of commitments that hang together and make sense of the phenomenon. I can go into lots greater detail about what that involves if you want in the question period. And the idea would be that if you understand a topic, then you have reason to reflectively endorse various commitments about the topic. Some of them may be propositional. Understand that 3 strikes and you're out if we're playing baseball. Or understand how judgments are made, so we have a richer methodological picture, but that part is kind of backburnered for now. And then we get an understanding variant of what we're talking about with respect to fallibilism. I understand phi. As I said, that's a subject matter. Within phi is embedded a particular proposition, and that proposition may not be true. That's what the understanding variant would look like. Again, as with standard fallibilism, it seems like exactly what you ought to be saying. You know, you're not omniscient. We got that far. But the question would be, well, why or how is this an advantage? And I want to actually approach this by taking the not be true bit seriously through a series of steps here and see what it gets us. And the first step is to look at Donald Davidson. And Davidson argued, in effect, I didn't put it this way, but this was a very evident consequence of his view, that to be in a position to make a mistake is a major cognitive accomplishment. Because you have to have, he said, a cluster of true beliefs about a topic in order to have any belief about it at all, including a mistaken one. So think about the following case. Suppose, as it might be, Joe knows a bit about quantum mechanics, and so he decides that, muons exchange quarks. That's not true. But you can't even believe that falsely unless you know a bit about quantum mechanics. If you're completely clueless about quantum mechanics, you don't have any way of anchoring that judgment at all. Or take another example. Suppose Mary believes that Mother Teresa was canonized before she died. We have to know a bit about Catholicism to know whether that's even possible. Otherwise, you just have no handle on the question whatsoever. So it follows from Davidson's view that in order to make a mistake, you've got to have a mastery of a subject matter. If you're completely clueless, if you know nothing about Catholicism, you don't have any idea what it might mean, pro or con, to make that claim about Mother Teresa. If you don't know anything about quantum mechanics, you know, muons, what in the world might they be? Now, Davidson's way of putting this, he says you have to have a cluster of true beliefs. And I think that's probably too strong. I actually think it is too strong. I'll throw out the probably there, but you might be nicer and want to put probably in. Because at the cutting edge of knowledge, and often not all that close to the cutting edge of knowledge, even if our beliefs are roughly in the right ballpark, they may not be quite right. So if you look at, say, Heisenberg's beliefs about quantum mechanics. Heisenberg was one of the inventors of quantum mechanics, very smart, let's go with all of that, but probably most of his beliefs about the subject matter weren't quite true. Still, you want to say he was in a position to have mistaken beliefs about it, whereas maybe I'm not, because his were true enough to give him a foothold in the subject matter. And similarly, if you know nothing about Victorian poetry, you don't have any false beliefs about it. You are just out there. But somebody who does, taking Poetry 101 may be in a position to have at least a few false beliefs about it, to make some mistakes. So the idea here is if we're trying to think about our cognitive accomplishments, we should recognize that the ability to make a mistake about a particular topic is, in fact, one of the cognitive accomplishments. And I think that's something that we typically ignore because we spend all of our time worrying about short answer tests. We go true, false, and that's pretty much it. But it's an accomplishment. Now that's actually making mistakes. Now we might back off a bit and ask about other cases. What about the mere possibility of error? Well, here I think we get a parallel sort of argument, because asking about where you might go wrong is interesting and important as well. Maybe it's an error, maybe it isn't, but knowing the possibility is going to be important. But before we go into this, I want to talk about an example about the importance of the cognitive value of error. This is actually a pretty real-life example. It is real life. Background. Here's a way of doing genetic engineering that's very, very commonplace. You insert a mutation into a bacterium. That's something that biochemists know how to do, and it's a very routine thing to do. So that's the background assumption. And what happens with this, once you've done this, the bacterium that has the mutation in it can then basically go in for what we might call bacteria sex, where it mates with another bacterium and exchanges genetic information. So the mutation spreads through this process called conjugation. Now, having that background, there was a case where in Marcin Faludowicz's lab, where they were trying to introduce two bacteria into, two mutations into a single bacterium at the same time. And it didn't work. And the guy who was charged with doing this was incredibly careful, kept doing it and doing it and doing it, and it didn't work. So what do we make of this? Well, if you were Popper, you'd say, okay, wrong again. We're falsificationists. We've eliminated one possibility. That only leaves us 87 zillion more possibilities to go, and eventually we'll get somewhere. But obviously, eliminative induction over mistakes is not a very promising way to go. If you're Aquinian, you say, something must be wrong somewhere in our network of beliefs, otherwise we wouldn't have made this mistake. But we can't localize it. This is just straight Quine. But of course, that's not what usually happens. And the reason it usually doesn't happen is because very often we can zero in on the locus of our error, rather than just saying something's wrong or something's wrong somewhere. Given that our various theories overlap in various ways, well, if I didn't have any problem with the one mutation and I do with the two, there's something about trying to do two at once that's a problem. I've located the error and not just said something's wrong somewhere. And that gives you a focus for asking what might be wrong. What is it about my commitments that is shown to be problematic by the fact that this thing that by my theory really, really ought to work doesn't work? So what you learn is to look more seriously at your network of commitments in this localized setting and see what you can find out. And I'll tell you the punchline. What they zeroed in on was that by doing the two mutations at once, they got the bacteria, the genetic information in the bacteria to over-replicate and basically explode the bacterium. So what do you do with that information? I mean, you add biochemical knowledge to when you explode, but you do more than that, which is you see if you can come up with a way of utilizing this to find out something new. And they did. They learned how to suppress the tendency to over-replicate and then use this as a device for what? Transmitting the tendency to over-replicate to bacteria that you didn't want around. That is to say, if you have this kind of innocent bacterium that has this propensity to over-replicate, and you throw it into something where you're trying to get rid of a disease organism, get them to over-replicate, and you make some medical progress by using this insight rather than saying something must be wrong somewhere. So the thing that I'm getting at here is that the mistake was a fruitful mistake. It wasn't just wrong again, or you get a 73 on your exam, or whatever. It was something that you could use to figure out more about what's going on in the domain. The other obvious example is the Michelson-Morley experiment, where they were attempting to measure ether drift on the assumption, reasonable assumption, light consists of waves, waves require a medium of propagation, call it the ether. Let's study this medium of propagation. Only they couldn't find one. It seems that there is no such thing. So what happens then? Well, I mean, more than the bacteria exploded, physics exploded, because it turned out you couldn't come up with a local fix. So you had to make radical revisions in your theory of energy and matter, which is to say physics, which is how, the theory of relativity is the solution. But the thing to notice here is not that the Michelson-Morley experiment should be classed as a crucial experiment in the way that Kuhn worried about. Rather, what you want to see happened really was something Socratic. Remember Socrates, it's better to know that you don't know than to not know that you don't know. Well, this was a very fruitful knowing that you don't know. What could possibly be going wrong here? And the first thing, and by the way, this experiment was repeated and repeated and repeated, actually up until about 1935, even though the theory of relativity was introduced to solve the problem in 1905. Morley didn't believe it. But they refine their instruments, they refine their thinking, they refine everything under the sun, because this really ought to work. And it never did. So you learn something about the inadequacy of your understanding of the topic by learning something about the obvious and then not so obvious and then really not so obvious fixes that don't work. And I think this is actually extraordinarily important as a way of thinking about why mistakes and the propensity to make and understand mistakes can be cognitively valuable. We could go back now to ask about the mere possibility of error, because so far I've been talking about actual errors and saying these are a better thing than you might have thought. But when we worry about fallibilism or the understanding variant on Moore's paradox, what I was talking about there was just I might be wrong. I haven't even said I'm wrong yet. I might even be right for all we know. But what should the might be wrong bit be doing here? And here again, I think if we take the might seriously, if it isn't just a general confession of human frailty, but is rather take seriously here where there might be an error, we learn something about the topology of our understanding. We learn something about where the fault lines are. We learn about, if this is wrong, where is it wrong? Think about another, other real life cases. Say, tests that have a few false positives. So let's take a medical test. Imagine, let's say, you've got a medication for, multiple sclerosis, let's say. It's a pretty serious disease, and you want effective medications. And you've got one that's better than the available alternatives in most cases, but has dangerous or at least untoward side effects in, say, 2 or 3% of the cases. So you as a physician, what do? Well, you might say, I know that this is a good medication. The probabilities are there. you tell your patient, I think this is the right thing for you to take, but you'd also say, look out for these side effects. You wouldn't just go with the math and say they're so improbable, why even mention it? That would be totally irresponsible. Suppose some poor guy has one of the side effects. You wouldn't just say, look, knowledge comes with a margin, a certain gap, there's a certain element of luck, bad luck. That would be really pretty heartless. But besides being heartless, it would also be losing useful information. Because you'd want to then ask, if you're serious about this, what is it about the cases that don't work? What makes these folks different? Is it really random noise in the universe? That's very unlikely. Or is it something that makes, Joe different from Bill about this? So it would be a way of investigating more deeply if you pay attention to the fact that you've got, something that falls within the gap between the, safe enough and safe in all cases. And this is what they do. They'll look further and they'll ask, what about these cases? What is the difference? Is it a difference in, genetics? Is it a difference in, condition, air quality? Who knows what it might be? But you're going to use this as a device for inquiring further. And if you blinded yourself to it, if you just said, hey, look, I told you it was going to fail in 2% of the cases, we're within the 2%, what the hell? No, you'd lose an available line of inquiry instead of asking, well, what is it about this case? So the idea is that by attending to what makes an epistemic failure, we gain a greater understanding of what you might call the topology of the space of reasons. You understand how these things hang together, which part of the thing you want to hold firm to, which part of the thing you might reluctantly give up. You may be backing into the Michelson-Morley case where the whole thing explodes in your face, but you might also have a local and limited revision that will still be very important to you. So the suggestion that I'm making here is that these things actually can be assets rather than liabilities. And I think that that's something that we tend not to pay as much attention to as we should. Now, the idea here then is to ask about, well, what can we learn from these cases? What can we learn both from the actuality of mistakes and even from the possibility? If we don't assume everything's equipossible, then we can ask about, how should we approach our understanding of the domain? What mistakes might be made? What might be responsible for them? And notice all of this is going to be keyed to issues about methodology. It's not as though you're just pulling balls out of an urn or something. You're asking about what we think we understand about the subject, what we think we understand about our methods for understanding the subject, and what we think we understand about the vulnerability of these methods. So it might be that the understanding of the subject is perfectly fine, but we misunderstood our own methods, or it might be that there's more that can be drawn out methodologically than we think. And this is something that I think is really quite important, because when you look at, go back to the case where the poor people with multiple sclerosis and the 2% error, and all you say initially, 2% of the people are going to have a problem here. That's all you know. Big sample size, that's all you know. And then you go and you say, well, what about the 2%? Now, one thing you might think at this point is, well, that requires further inquiry. You're not asking the same question anymore. You're just sort of saying, back to the lab, Fred, whatever. But it may also be that what we really need is to rethink what we're doing with the evidence at hand. It might be, and not infrequently might be, this is not a philosopher's hypothetical, this is a kind of not unreasonable thing that goes on in statistics all the time. Sometimes you can run more refined regressions and find out that there really is, in the evidence, more texture than you've seen. So instead of just going for the sort of gross probabilities, you do more refined statistical analysis and you find out, oh, these 2% really are quite different in some way or other. Or you might find out that there's a conceptual error that you've been making. I'll switch to another example, for not multiple sclerosis anymore. Talk about meningitis. I seem to be on diseases today. Used to be that meningitis was considered a single disease because it exhibited the same signs and symptoms. It's sort of a continuous range of signs and symptoms. And then there was this mysterious fact. Some people had a more serious case than others. All right, that sort of happens with any disease, I guess, or many anyway. And also, some of them responded to antibiotics and others didn't. All right, now that was the key finding, because that was what led to the discovery that there are two diseases, viral meningitis and bacterial meningitis. They are different diseases. They have the same signs and symptoms. When all you knew was the signs and symptoms, it was perfectly reasonable to call them the same thing, but you're not suffering from the same disease, and therefore the severity of the disease, the prospects of recovering from the disease, the proper treatment of the disease is different depending on which one you've got. So studying more carefully what you thought you might have known but you didn't know may put you in a position to question a background assumption. We're talking about the same thing in all of these cases. No, it turns out you're not. And just looking more carefully, taking more seriously, how come she responds to antibiotics and he doesn't? Does he have a general unresponsiveness to antibiotics? No. Okay, then that can't be it. So how come? So how come? So how come? That's all available to you in the evidence you've got if you want to look at it. So the suggestion here is that the various ways we're making mistakes can be useful as giving us targeted information about the phenomenon we're interested in. And not just sort of, you're wrong somewhere or other, well, for all we know, it's a demon world. Nobody's talking about demon world. They're talking about what we might learn about in this world, about these phenomena, given what we have. So the suggestion is that both error and the possibility of error can be epistemically valuable if you are willing to take them seriously. And there's another way, of course, that they can be epistemically valuable as well, which is a sort of more obvious way. Think about what happens when you discover that you have a vulnerability. You learn, or you try to devise methods for handling that vulnerability. Well, I mean, the first vulnerability, you double check your results. This is what we've been hearing since we started school. Don't, you know, however confident you are of your conclusion, just double check it. And that will certainly handle some cases. Do the same thing over and over again, add the same numbers again, or whatever. That'll handle some cases, but it won't handle all of them for the following reason. It'll handle careless errors, but not systematic misconceptions. Because doing the same thing over again with the same misconception is going to give you the same answer, pretty much. So what you want to do then is devise other ways of approaching the same problem. Then you have cross-checks, because the misconceptions that were dominant in one way may not be operative in the other, which would suggest that maybe you'll get a different answer in the two cases. You still don't know what's wrong, but you know that something's wrong somewhere here. So we have, you know, a double checking by multiplying perspectives, multiplying approaches to a problem. And this is why there's something that's often said in criticism of, say, naive philosophy of science that carries on about replicating experiments, because it points out that most experiments don't get replicated because it's too expensive. It's true. However, What does happen is either that the problem is approached from another point of view, or somebody tries to build on the result, and it comes crashing down. That's, in effect, challenging the conclusion, so it is, in effect, playing the same role as replication. And the suggestion is, in all of these cases, there is something to be gleaned about our own understanding of the subject matter at any given time that is vulnerable to these things, that we can make these checks, that we can't make those checks, they work, they don't work. You might also want to hedge your bets. Think about, remember I said, the understanding variant, I had the but I might be wrong bit in. And we want to ask, don't I get the same sort of problem that we got with the Williams challenge to Moore? You're giving it with one breath and taking it away with the other. And the answer is not, obviously, because here's what can happen in the understanding variant. We'll worry about whether it's something I should say or not in a minute, but let's just look at the content of it. The idea I said was, I understand that phi, and phi has p as a component, but maybe p is wrong. Well, what should I do if I'm going to be using this? One, hedge my bets. See whether I really do want to stick with p, which might depend on such things as worries about the importance of false positives and false negatives. If being wrong about p is very costly in one way or another, I might not want to go with it, since I recognize, given the whole body of understanding, that it can be very costly. If p is very tightly interwoven into my web of commitments, I'd have to be wrong about a lot to be wrong about p. And I don't think I'm wrong about a lot. So I might be reasonably confident about p. So take two cases where this might occur. Think about challenges to evolution. So, people say, oh, you scientists, you're all fallibilists. Couldn't you be wrong about evolution? And the obvious answer is not easily. Because first of all, you have a vast amount of biological evidence from, genetics, ecology, anatomy, physiology, so forth and so on. Then you have evidence from geology. Besides being wrong about all of that biology, you'd have to be wrong about geology, because the formation of finding fossils in sedimentary rock is going to be rather hard if there weren't any dinosaurs. You'd have to be wrong about chemistry, because of the role of organic chemicals. You'd have to be wrong about physics if you have to be wrong about carbon dating. Could you be wrong about all of this? Yes, but now we're backing into a demon world. It's not going to be easy to be wrong about all of this stuff. So it's going to take a very strong argument to make that case. Take it the opposite extreme. Take an urban legend. Here's a nice urban legend for you. There's this story that the sewers of New York are populated by alligators. How could the sewers of New York have been populated by alligators? Well, a lot of people in New York go to Florida in the winter, and they bring a little alligator home, and it gets too big to actually keep in the apartment any longer. So they flush it down the toilet, and they all just live and breed and populate the New York City sewer system. But this is an urban legend, and suppose you believe that. All right, how could you be wrong about that? Pretty easily, because all you've got is your source who told you this story. So you find out you're wrong about that, or you find out your source is unreliable, and you give it up. And nothing else has to be given up, except she's a reliable source, and there are, as far as we know, no alligators in the New York City subway system. Two beliefs, they were pretty isolated, they were very easy to give up, so there's no problem with that. So what we can do here is we can ask about how tightly interwoven our commitments are, And that tight weave is going to give us a measure of how likely it is that we're wrong. But it's going to be a measure that is compatible with being wrong, because actually the theory of matter that was presupposed before the theory of relativity was a lovely, tightly woven theory. And it was wrong. Or you want to go to Aristotelian physics that was also beautifully, tightly interwoven, and it was wrong. So I have to be wrong about a lot. To be wrong about this only gives you, let's say, a presumption, but it's overridable. And if we look at the history of thought, we say this sort of presumption has really been overridden in the past, so it's not just a paranoid philosopher's overridable, it's something with a track record. Still, there's reason to accept certain things and not others. So the question is, well, what does, I understand that phi entails p, and p could be wrong. What about the give it with one breath and take it away with the other? Isn't that still embarrassing? And I want to suggest, okay, not really, because I think the way you should understand Moore's paradox in generally is in terms of Grice, and in particular in terms of Grice's second maxim of quality. And that one, it doesn't get a whole lot of press, but I think it's very important. It says, do not say more than is appropriate for the conversation at the point that you're in, which basically means if it goes without saying, don't say it. Now, why not? Answer, if something goes without saying and you say it, you make it salient, and you give it, you seem to attach some importance by saying it. So if you say, you know it might rain tonight, it always might rain. If that's all you're telling me, then there's no point in saying it. But if you're telling me there's some particular reason to think so, then maybe I better take my raincoat or something. So the idea would be that what the problematic character of the Moore's paradoxical sentences is they make salient something that really ought to go without saying. And they're problematic for this reason. If it's salient that you might be wrong, if there's something about this case that makes it a clear and present danger that you're wrong, then you shouldn't claim to know. If it's just sort of standard background that people have been wrong before, then it goes without saying. So the suggestion would be that there's a problem with uttering Moore's paradoxical sentences that's compatible with those sentences actually being true, because they give the wrong emphasis. And that emphasis can be misleading. You start looking around for, you know, what's the problem here? What's the problem here? Which you probably shouldn't do if it's only, it's always some possibility of being wrong. So I suggest then that if we look at understanding, we can see why fallibilism is a valuable stance, because by heightening our attention to where we might be making mistakes, not just to the sheer possibility of error, but to the likelihood of particular errors in particular fields, we gain a better understanding of our own understanding of a subject. And that's really worthwhile. Thank you.